So let us start with what do you mean by arithmetic progression. So several sequence you can heard. You already know that some sequence or series we can say. Correct? For example, we can write here. So I am writing some examples here. Is it? So we can write 1, 2, 3, etc. These are natural numbers. Is it? So then another one I am going to write 2, 4, 6, 8 and so on. So on. We can write the next one. Right? So these are even number. And the same way odd numbers we can write 1, 3, 5 and so on. It's going on. These are series. Is it? Series, or we can say it's progression. It is increasing. It may be increasing or decreasing. So several sequence or series we can write, right, in this one. So what do you mean by arithmetic progression? What's the meaning of progression? Arithmetic progression. Let's go for. What do you mean by progression? Progression, it is nothing but the sequence in which the general term can be expressed as the using some mathematical formula. So general term is simply saying some general term can be expressed using the mathematical formula that are called progression. Then what do you mean by arithmetic progression? So arithmetic progressions you can see, that are progressions, arithmetic progressions are the progressions in which the difference between two consecutive, what do you mean by two consecutive terms? Consecutive terms. What's the meaning of consecutive terms? Consecutive simply means nearby terms, isn't it? Then number near to the other one. Both these together we are saying they are consecutive terms. Okay, so here it is in this sequence or series we are saying this progression. In the previous one also you can see several numbers were written by separated by commas here. Right, each numbers are in this one in this series sequence is called terms. Okay, so that's why it's saying each term consecutive terms. So each consecutive term is differ, isn't it? It is the difference we can say between the consecutive. That is called common difference, is it? So that should be a constant. That means each term, how many terms there, the consecutive terms difference it will be a single number, right? That number which is called the common differences. So for example, we can write here 2, 5, then 8, 11. So you can see in this each one, this difference between these two, we can see it's 3. Difference between these two also 3. Isn't it? Here it is 3, here it's also 3. So what we can say, this is a progression, arithmetic progression. Isn't it? In this case, we are getting the common difference. It is, common difference is 3 here. Is it? So look at this case, we can see it is 3. And another cases here, I wrote here 2, 4, 6, 8, etc. Is it? And 100, 80, 60 and so on, so on. And 3, 3, 3, 3 repeating. So all these are sequences. So what we can say, is any common difference here in this one? Common difference is 2 here, isn't it? That is positive 2. So what we can say, this is an AP, is it? This is an AP. Now what about this one in the second case? Any common difference? It's getting minus 20, correct? So common difference we are getting minus 20. So this is the common difference. So this also we can say it's an AP. Now this one in this third case, the common difference we are getting it is 0, correct? So that also AP. All these three are we can say arithmetic progression. From this what we can conclude, the common difference be positive or 0 or negative. When positive, when the AP is increasing order. Is it? AP it is in increasing order. You can see the first one. 4 it is more than 2 and 6 it is more than 4. So that means it is increasing. AP it is increasing, then we can say that common difference it is positive. And no change, you can see no change in that one, constant, it is moving constantly. Then what we can say, common difference it is 0 here. Then next one we can see if negative one it is decreasing. The second term it is less than the first term. Third term is less than second term. Then we can say it is decreasing, right? Yeah, it is decreasing. Then common difference is negative. So common difference may be positive, 0 or negative. So according to the terms given, it is increasing or decreasing or no change. Okay, so this common difference understood well. Yeah, let's go for finite AP and infinite AP. So finite AP we can see here, there it is ended. You can see it is terminated, right? So 2, 5, 8, etc. etc. It ends with 38. 1, it is the last term it's getting here. So a finite AP is an AP in which the number of terms is finite, right? There should be a limited number of terms there. So this is the example, and the same way infinite AP there should be, yeah, infinite number of terms there. For example, here if it dotted lines, this means it is never ending, it is going, correct? No last term. So that's why we can say a finite AP will have a last term, whereas infinite AP does not, is it? It does not have any, yeah, last term. So